Good morning. This is September 20. What is it? It's September 25th, yeah, 2017. And I'm going to do a brief little presentation about a segment of a curriculum that I work on these days in the field, going from school to school. This is a company effort, and I draw inspiration from my coworkers and so forth. But, as part of doing all that, I have my own projects in Codesters. So this would be like a typical student collection, things that any Codesters user would probably have, just a bunch of stuff they're working on. Now I'm going to, for this video, because it's almost Halloween and we're going to do that as a theme, so I'm going to do something around jack-o'-lanterns and bats, okay? I hope that's not too scary. There's no clowns in this video. I also have my Scratch account open, and I'm going to just go straight to create, because what we do in this section is of the curriculum that I'm talking about is we transition from a block-based language, Scratch, MIT Scratch, to Codesters. And making this switch, we're doing a lot. We're abandoning almost the jigsaw puzzles. The block-based language concept is you assemble what looks like a jigsaw puzzle. And like Blockly from Google is very explicit about it looks like jigsaws. Let's just quick go there. Blockly, Google. This is another block-based language, right? I think I'm at the right place when I go here. Look at those little blocks, right? And there's also MIT Scratch, or excuse me, that's what we're doing. What am I talking about? There's Berkeley Snap. Let's check that out. Berkeley Snap. These are all examples of block-based languages, and you're going to be programming your Android telephone, smartphone, I should say, using a block-based language, some of you. So there's the Snap. Looks kind of like Scratch. So there's a whole phase of programming that you can do, and you can come to it out of sequence. Usually we do this first, right? Because we don't know how to type that fast. We're not that great with the keyboard. Now we're developing that skill, and we're going to get better at typing. So at some point, when we feel we're ready, we're going to look at these non-block-based languages that you type pretty much, right? So this is where we're doing that in the curriculum. We're transitioning from here to here. And what I want to talk about is something very specific, which is how to not have your sprites step on each other's toes, by which I mean when I write code for this guy, Scratch, by dragging blocks out, like I go to Control, you all who've played with Scratch know this, you can forever do this loop, and inside that I want him to do something, him or her, I can't really tell, and just turn 15 degrees forever. Now that's going to happen really quickly. The rate at which things happen is important in computing. It may not be in mathematics. Everything's eternally fast, and you just have every result. Everything happens immediately. But when the machines become involved and actually have to do the work, my goodness, things slow down sometimes. But we want them to slow down, is what I'm saying. We want to be there to watch it happen, for one thing. So let's do 0.1 as a wait time, and this will, when I hit the green arrow, I don't even have to hit the green arrow, I can just hit this loop now. Okay, there he goes. She or he. Now I can do other things, it's like a puppet, but the whole point here is when I add a new sprite, okay, let's stop the activity and get us a new sprite. Okay, let's get an airplane just because there's one there ready. Okay, I can just put a different activity inside of this airplane as distinct from what's inside Scratch. That's the name of the cat. Sprite number 1 in this case. I can segregate the code for these simply by treating each one as its own code container. Inside of Scratch, we've got this forever loop. If I click on the airplane instead, you see there's no code there yet, but let's have some. let's just have the plane do something 10 times. And to make it obvious that it's doing something else, let's turn the other direction. Whoa. And let's also have some wait time in there so that we can observe this happening slowly and understand what's going on. All right, here we go. I'm going to start the code on the repeat. And there's the plane. Oops, I hit it twice. There we go, plane. Now, I don't know why the plane stopped. Oh, that was 10 times. That's why. Oh, this is boring. Let's do it 100 times so I can get some work done here. Come on, plane. Start over. There we go. Now we'll quick go to Sprite here, scratch, and get him going. So they're going together, right? And that's what's easy here. There's automatic what we call segregation of scope. Scope is like if you're all talking in a crowded restaurant, but you can't quite hear the other tables that well, but you can hear your table, then everything's fine. You can have 100 conversations going, and there's no problem with nonsense. Just because everyone can't understand if it gets too, if everyone's volume, voice volume is the same, and they're all having different conversations, and you can't really control. You know what I'm saying, right? It gets to be chaos. And we have the same problem with computers. Now, we'll stop, you guys. So what happens over in Codesters is we don't have this nice segregation off the bat. What we have is sprites coming in. Over here, we click sprites, and there's the same thing. Our choice, airplanes, so forth. Now, under Halloweens, we can have some ghost, skeleton, candy, pumpkin, whatever, throw these on, and as you slide from A to B, like I open this here to see what the code looks. Now we encourage just start typing this code. Yes, it takes longer, but that's the practice. Or slide it over, put it where you want it, and boom, there's the code right there. But notice we're creating a sprite, and we're giving it the variable name Sprite right away. So if you have 2 or 3 different sprites, here's the problem. They don't each have their own code space, and they're all there together, and they're all just called Sprite by default. Here comes a witch, and so forth. So they're all called Sprite. This is not going to help tell them apart, because when we want one to rotate and the other to rotate the other way, if they all have the same name, it's like going into a classroom where everyone's named Jimmy, and you say, "Hey, Jimmy," and they all say, "What?" All at once. Anyway, ignoring this code I've added, which is going to get us. Let's just run it. What's going to happen here? So we're going to get. There's the witch. Okay, she's going to get covered up. And notice each one of these pumpkins does individually rotate and shrink, and then some of them are replaced by bats. Now it's somewhat hard to see that, the bats that is, because I have a haunted house background, there's witch. Anyway, Frankenstein must be there too, but you see these sprites, they create right on top of each other at the center of the screen, so we don't really see Frankenstein. Let's just see Frankenstein all by himself. How about that? Let's comment out. Because I haven't seen Frankenstein either, so I'm interested. So let's hit the screen arrow again, run it again, and there's Frankenstein. You're not very scary, really. This is a fun kid family game here. So Frankenstein. Anyway, Frankenstein was not the monster. Frankenstein was the doctor, the character who created the monster in the book by Shelley. Very classic Victorian horror film, novel, I should say. Okay, well, there we go. I'm going to wrap it up there, but just keep the lesson in mind that we're going from a block-based language that has its own idea of scope simply because you can hide the code behind the various puppets. Makes it easy, really. And then immediately you've got this problem of variables having the same name and stepping on each other's toes over here. You don't get the separation of identity quite so strongly because it's all just looking down on this one sort of, canvas. So what do? in this code, you see, if you check it out, that I'm starting to add sprites to a list, and then I'm iterating over that list to make each of these do its own little dance, right? So I don't even have to give them names, really. I just stuff them in a giant, like, egg carton, so they're all there. You don't name individual eggs when you buy them, right? You just use them, get rid of them, put them to use, right? But you don't name each one, right? What's purpose would that serve? So that's kind of the approach I'm taking with sprites. In this script, I'm just putting them in a giant egg carton, and then I iterate over those sprites. And at first, I set them to 75% of their original size. Let's run this while I'm talking. I am wrapping this up, but I want you to understand the code, of course. So I'm putting all these pumpkins or jack-o'-lanterns in a list, and I'm shrinking them and spinning them by iterating over them. Okay, so that's what you'll get if you understand Python. That's the language we're using here. So it takes a while to get the literacy there. But these are what we call for loops, right? And here in the last for loop is where I'm saying one chance in 3, you're going to change into a bat. Okay, I'm going to load a different image for that sprite, which is tantamount to changing the sprite. It's a different image. Okay, so we've got the bats much more visible here than before because I don't have the busy haunted house background. All right, talk to you some more. Have a good Halloween.